And the idea is to keep it in the green. Water in this range is readily available to the roots, but it's a fairly narrow range. And this is at only about a ½ inch per foot for real sandy soils, and for some of our heavier clay soils, it might be as much as 1.25 inches. But the yield is maximized when the soil moisture is kept in that range. Root growth is a function of just a healthy plant, having a healthy plant and moisture in the soil for the roots to grow. And normally, the maximum root depth is achieved by by bloom stage. Whenever the plant goes into reproduction stage, it's probably put its roots down as far as it's going to. There generally, when we got so far as where the plant gets this water from the root zone, 40% of it, if you had a soil profile that was uniformly or had the same water content and uniform throughout, it's going to pull 40% from the top 25%, 30% of the water is going to come from the next 25% of the root depth, effective root depth, and 20%, and so on. So, if corn during its mature stages has a 4-foot root depth, then we're talking that 70% of that water is going to come from that top 2 foot. And since we're refilling this zone all the time, there's probably very little water coming from this, in terms of inches, coming from the bottom 2 feet. Anyway, it's our objective to keep the soil moisture in that narrow range. And to do that, we have to take into consideration the available moisture, precipitation, evapotranspiration, irrigation capacity, and the future needs of the crop. We have to take all that in consideration into making our decision. And we'll talk a little bit about the soil moisture stress. Yield loss is directly proportional to moisture stress. And we're just going to, and there's a yield factor, a yield reducing factor that we can use to calculate the yield loss each day, depending on the amount of ET deficit, the amount of water that the crop was unable to pull out of the soil because it was stressed. And I'm just going to blow through these, but these are some of the yield loss coefficients we use. The literature and stuff, in this area, in these early stages, they won't have these quite as high. But my producers, for what we were using they wanted to make sure that we didn't stress in this area, so I kept those pretty high. But here's a graph that we from the aquaplaner. This line represents the soil moisture content. This gray barrier right here separates history from future. This is today. This is a wheat field, and this line represents the root depth. And we started out. This wheat was planted after corn. We started out with a profile that's only about 50% full, and so we watered it along here a couple of three times. Then we got some real nice rain. We had sufficient rain that we were able to put some of moisture back down in below the root zone. And then these are sprinkler passes that the aquaplaner is projecting out here in the future that we need to make in order to achieve the objective of having the soil profile pretty full at the first node, and again full at heading, and then keeping it in good shape throughout the grain filling stage into maturity and be. And so aquaplaner has these those graphs. There's that graph again, and we also model the moisture at the top foot, second foot, third foot, and fourth foot of the root zone. And we also have a water requirements report where we calculate this sprinkler has a capability of delivering 0.31 inches per day. We're 80 days to the first node, and during the 80 days we expect the crop to use 6.7 inches of water, well, that's 0.8 inches of water per day. And so we know we can tell by comparing those two numbers that we have plenty of capacity to meet that need, so there's no real need that we need to be running today. We can wait for rain. We also have a limited resource scheduler. This is what we use this in conjunction with the High Plains Groundwater District. What we did, we ran the model without any irrigations for the first year. And then we went and calculated the yield loss each day and found the day with the greatest yield loss, scheduled an irrigation for that day, and then reran the model, and we kept running those iterations, finding where the greatest yield loss was, and scheduling irrigations until all 12 inches of water was used up. And it worked really great for last year. We also have a resource allocator. My farmers really slammed me with this last year, and David was talking about it a little bit, but where you've got a field, maybe a sprinkler that's split between cotton on one side and corn on the other side, or you're gonna plant corn early and then plant the other half of it late, and try to extend that peak use period out. And so we have a program that will do that. We can set it up, and it'll go out and it'll schedule irrigations for both sides of the circle, knowing that it's got to be water in both of them. And I'm pretty excited about that this year. We also have a field simulator where we can set and we can simulate the production for the entire season, and just see what varying the planting date, seeing what varying the acres, number of acres planted, or other inputs. We can vary those and see how that's going to affect our yield. And now some of the questions you've got probably are, well, how accurate is this modeling deal? Last year we had the soil moisture blocks out where we were running some of these, where we were running our model also, and it was really, they matched up very well so far as the soil moisture content measured by the blocks, and it's what we were modeling with the aquaplaner.